Prototyping Urban Infrastructure for User-Centered and Sustainable Designs by Miguel Guerra. I am a professor at the University of San Francisco de Quito, and this research was done in collaboration with Virginia Tech. Who can tell me where was this picture taken? Or how about where this other one is located? These two pictures could have been taken in most of the cities of the United States. Designers and engineers keep designing urban infrastructure the same way everywhere. This happens because engineers are risk-averse. To develop our designs, we use zoning, codes, norms, and ordinances, and we keep copying the same designs over and over. A big reason is because our professions deals with avoiding loss of property, loss of cost, and loss of life. So, it is very challenging to overcome the risk and uncertainty to break from the traditional designs. Another challenge for engineers designing urban infrastructure is the little feedback from the user's experience during the design phase. Also, limiting our design to norms and codes limits our understanding of the preferences and needs for those that we design for, those using our infrastructure designs. These pictures do not show uncommon cases, but rather a case that reminds us many places from our daily lives. Prototyping is a field in engineering that started way back in the 1950s, and it is not until the 80s and early 90s that other engineering fields brought it back as a key component of their design processes, such as design thinking, with new lens where prototyping is used to observe the user's experience to design the features and their mutual interaction. In infrastructure design, civil engineers have been creating scale and virtual models, as well as architects, to prototype infrastructure design. The problem with these types of models is that the key is that they limit or they lack the ability to observe the user experience. You can design this virtually, but you can't see actually how the user interacts over time with the design. But you can do this with physical prototypes. So, this research, in an effort to contribute to the design of sustainable infrastructure systems, the objective of my research is to operationalize the use of prototyping as a design method by defining the dimensions of what prototyping means and represents for infrastructural design. This can be used for practitioners and for researchers. For practitioners who want to adopt prototyping, these dimensions offer a guideline for the design and implementation process. And for researchers, these dimensions can help classify projects and future research can correlate the outcomes of the design processes to these prototyping dimensions. For this, we compare about 55 cases that represent 4 types of infrastructure. To select the cases, we filtered the project using a definition of prototyping for civil infrastructure that I developed last year that highlights 3 important aspects. The first aspect is thinking on the user. Complete the feedback loop for the flow of information between the users and the designers. Translate feedback into the final of the design of the same project, which is reducing the designer's perceived risk by removing the fear of failure of a permanent installment. And then dual system. This is a product and a service within a whole system thinking perspective, which is allowing understanding this dual nature of being both a product and a service at the same time. It is different than virtual BIM because with this lens, prototyping cares about the user experience and the observation of the user, which cannot be gotten from the virtual BIM, especially for infrastructure, which is a unique system in the sense of being both a product and a service. First, the first dimension is the level of formality. This refers to the degree of officially permission to build the prototype. The more official, on the one side you have the more official ones, which are projects that have been led by a city or a government. The Times Square prototype in New York City is a good example of this more like a top-down approach, where a city designs, plan, and implement the prototype that consisted in closing the streets for vehicles to turn them into 100% pedestrian streets. On the other side, we have actually the informal aspect, which is like a kind of a guerrilla case, where a particular group is advocating for a solution. And this is a great example where they build this protected bike lane in Omaha by an advocate group by gluing down to the street over 200 plungers. This lasted about a couple of days until the city took it down, but this is a type of informal prototype that you can see is showing the user the experience of having that kind of infrastructure there. The second dimension is community involvement, and this refers to the degree of community participation in both the prototype design and the prototype implementation and construction. For example, on the high side of the spectrum are projects like this urban revitalization, where the community participated in developing the design. There were many community meetings for the design feedback, but also there were over 100 volunteers from the community who participated in the implementing the prototype, building it, and also in the testing and assessment for feedback phase. This other project that was done in Brazil is an example of a medium-low side of the spectrum. Here, they extended the sidewalks, removed parking, and dieted the streets from 3 to 1 lane. Although the process took 1 year, only the business owners participated in the design of the prototype. The third dimension refers to the duration, to the time that the prototype is left in place for the user to experience. And this can vary from hours to a very few days to many years, or even leaving a prototype permanent. A permanent installment on the one side of the spectrum is a great opportunity for prototype government housing projects, because the high number of units to build, for 1,500 for example, can be built in blocks of 20 to 30 units that can be used like prototypes. In these particular cases, these installments are built to the higher standards possible, because although they will serve to observe and get feedback from the user experience, there will be users permanently using these houses. On the other hand, we have a very short-term prototype that can be an urban revitalization that lasts 2 days, or the plungers to build the protected lanes that lasted just a few hours. Right? So the fourth dimension of prototyping is the resources. And in this spectrum, we permanent prototypes go from low to high. On the one side, on the high side of the spectrum, the amount of resources is important, because they should offer almost the same quality or guarantee as a final project. On other projects, although they are very comprehensive and detail-oriented, include the use of volunteers, local existing materials, or cheap superficial supplies. This is an example of medium scale resources of the spectrum. Or, on the other hand, we have with low resources, like this redesign of this intersection by a neighborhood only using chalk and leaves, as we can see in this picture. The fifth dimension is the number of participatory stakeholder groups. There are 4 categories or stakeholder groups: internal direct, internal indirect, external direct, and external indirect, as we can see in this chart. And this dimension refers to the number of stakeholder groups who participate in the design, planning, implementation, and testing phases of the prototype. An example of the high side of the spectrum is the government housing project in Iquique, Chile, where stakeholder groups from the 4 categories participated in the prototype: owners, investors, planners, architects, governmental offices, and so on. On the other side, in this prototype in Chicago is an example of a medium-low side of the spectrum, where stakeholder groups come from only 1 or 2 categories, such as government agencies and the direct business owners in that block. So, and the last dimension, number 6, is the purpose of prototyping. And for this, we have early, further along, and late stage on the prototyping. Here, we can see that an early stage in the design phase, the community-led prototyping was observed to intentionally change norms, regulations, or procedures of the local government. A more further along in the design, when is a more formal happen with more formal prototypes that usually are led by the city, and the prototype intends to get the community on board with the project and provide feedback. While in a later stage, a prototype can intend to close the feedback loop for designers to translate the feedback from users' experience into the final design of the prototype. And we have here we can see this hexagon model in which we are designing and we are looking into the 6 levels of this formality. Those numbers that you see over there are the numbers that are going to that are the number of subdimensions on each of these dimensions. So, purpose of prototyping, we have 3 types. The number of participatory stakeholder groups, we have 4 groups, and so on. And we tested these two with 2 case studies. The one case study happened in Akron, Ohio, where the hexagon shows that we have a high community involvement, number of stakeholders group, and a combined purpose to challenge norms and get the community on board. We have medium the dimension for resources and the level of formality. And then the duration of the prototype is in the low side of the spectrum, because here we can see that it only lasted a few days. This prototype was to design an urban infrastructure to revitalize a neighborhood. They implemented lighting streets, building public plazas, bike lanes, public places, and green landscapes. Right here. Then the other case that we have is in Akron, Ohio. No, is in the same case. And we completely changed the shape of the street, include buffered bike lanes, and put infrastructure for pedestrian and community building. When interviewing the designers, they said that it was very challenging to get this design approved because it challenged many of the traditional ways of the engineers. However, since this prototype, the city transportation engineers have participated and contributed with 2 other prototypes. So we can see the change that happened that came from the prototype. We can see this big difference right here. Also, this prototype was also brought the users and brought the characteristics of the users in the neighborhood. It turns out that here we had refugees from 5 different cultural backgrounds, from Bhutan, Nepal, Italy, African Americans, and white Americans. And this feedback helped the design public spaces of infrastructure that are adequate to the user's preferences and needs, such as performance stages, seating public plazas, international product stores, and so on. But also the similarities which brought the community together, building buffer bike lanes to move from one place to the other. We can move one place to the other, were built here too. We can see many people, and they said that this was the first time that these groups interacted in the neighborhood. So we can see in this case study how the community got on board, got together, and were able to provide feedback to a design that became more sustainable, that became more accepted, and therefore more used by the community, bringing the community's feedback, adapting and adjusting for what the community wants, needs, what their community preferences are. The other case study happened in Macon, Georgia, and this prototype in this hexagon, we can see that we have a combined purpose to challenge the norms and also to get the community on board. It's a medium high in the number of stakeholder groups and community involvement. It's medium in the dimension for resources and the level of formality, and is low of the level of permanent because it was only 5 days. This prototype was to design alternative ways to connect the surrounding neighborhoods with downtown. So they prototype 8 different types of bike lanes along with 5 miles. It turned out that the bike lane they thought was going to be a very, very, very well welcomed, like a big success, received very negative feedback, which was this bike lane right here. It was a buffer bike lane on the middle of the street, giving the most important part of the street to the bikers, making them the most relevant part right there. However, the feedback said, the bike lanes along the mid lane, which was supposed to bring hierarchy to the cyclists, they say no. People felt unsafe to be cycling between cars. And also people said they were very confused on how to proceed through the streets intersections when they had to turn and such. So where is this project taking me or taking us? Where to go from here? And the first part is we want to see other types of prototyping. We want to see how this relates, how prototyping of infrastructure relates to this hexagon that we have right here, and actually understanding the dimensions with these other types of sanitary, transportation, government housing, and urban infrastructure revitalizations. How do they fit with this hexagon for dimensions of formality, and how applicable this is? The experience of the user. How can we operationalize the simulation, escalated models, combining with this hexagon right here? And then we want to explore other forms of prototyping using alternatives that recreate the user experience, such as virtual reality, augmented reality, using a lot of the technology that we have. Physical prototyping infrastructure can help designers by removing the fear of failure that exists designing permanent large-scale projects, allowing designers to break from the status quo, quote, to include more feedback from the users to deliver sustainable designs, giving us an opportunity to understand the users and deliver the best design that fits for a particular group of users and their context, allowing us to consider the user's needs and preferences. My name is Miguel Andrés Guerra. Thank you. If you have any questions, please direct them to that email address. Thank you.